Hi, I am Bryce Berning, and I'm going to talk about my summer internship with Reynolds Construction. This summer, I was a project engineering intern with Reynolds. They're primarily located in Orleans, Indiana, but they also have various offices across the United States. Oh, The office I interned for primarily does heavy civil construction, which is what the project I was on. I was on the Sprider Creek CSO project that is located in Bedford, Indiana. The plan was to build a storage tank and a new pump station. Uh, the reason for this is the current pump station cannot handle flow during certain rain events, and it would cause overflow into a nearby creek, which is on this green line right here. Now, this red box is where the job is supposed to go. This is where the storage tank will be, and this is where the new pump station will be. The storage tank is going on a large hillside that we would need to go down 40 feet to get to the right elevation, and the storage tank would need to go, or the pump station rather, would need to go down roughly 30 feet. And the best way to do this is to blast. Now, Bedford is one of the largest tributaries in limestone, so the stone is very high in this area. The best way would be to blast. As you can see, there's residential areas to the north, businesses both sides, a highway, and a bridge here, and then an elementary school. So we would need to be careful with our seismic readings and keep them under one, and we could only blast during certain times of day. You were only allowed to blast 10 to 11 and 2 to 3. Now, we also had to shut down this road. I was usually in charge of shutting down the road right on this side. Um, the process of blasting was we would have a drill rig that would drill down, dig a hole. In some areas, we were 24 feet, and most of the time it was 15 to 10. We would drill the hole, then you would put in a detonator that had a wire that would connect to the others. You would fill it with a explosive primer or a dynamite. Then after that, you would put in a blasting fertilizer, is what they would call it, and then you would add stemmings. Stemmings is stone size 11, and how that would work to hold in the blast is when the blast goes off, these stemmings will lock together and prevent the blast from going up and make the blast go out, which causes all the rock to break and then explode. Now, in this picture, I am helping the blaster make sure his rig is completely vertical and that the drill is exactly where the hole needs to be. Now, I was on the job site every single day, and I would usually help the laborers or whatever do any job that needed to happen. Now, when the blasters are there, I was out setting the holes, filling them with stemmings, doing everything to help keep the job running. Now, being in the field did have some fun things. I was able to learn how to drive a skid steer. I was able to learn how to locate from the field engineer. I built a roof and I built a handrail with some of the other carpenters. But I also did do some dirty things. As you can see right here, I had to drop the pumps to keep the pump station water down. The creek is on this border on the top side, so it would seep in, causing the water to get 2 to 3 feet tall at some areas. So it was above my knees, and I had to walk out in the water and set the pumps. Now, this is a blast right after it had happened. As you can see, it looks like the blast had folded onto itself, which is how they control the blast to go exactly where they want it to. Now, if you're looking at this, you can kind of see that it looks like there's a lot of soil and rock from what it had started with. Now, the rule of thumb is that when you blast an area, the rock and stone will double in size. And this is what the storage tank area looks completely cleared out. We had two dump trucks running every day, all day. We were able to store all this stone and rock in an area on the edge of the site, which actually gave us more storage, which is very helpful. Now, to improve the safety of this cliff, we had a 40-foot tall cliff with loose rock on it. So we added Visqueen rolled down to help any falling debris and keep it from falling and helping anyone that's working underneath it. Now, I was with other laborers in harnesses when we were dropping all of this queen down, and I also helped drop this queen down in this pump station. We're on these edges, dropping it all down. Now, once we had finished all that, they started setting forms and pouring all the concrete into the forms. Some more of this. Now, I was there for two pour days. They would usually start at about 12:30 a.m. and then go to 1 or 2 p.m. So a very early morning. I was in charge of staging the pump trucks and keeping a truck there as much as possible and making sure they were able to find their way to the job site. Here is one truck that is staged, and as you can see, we have one access point to the pump station and the storage tank. So we had to be very strategic with what we brought down, what's going to be there, and what's going on that every every day. So with this rebar that was coming to as the next step of the process, we had to make sure that it was there each morning and it was the rebar that needed to be there that day, and it wasn't any extra because we didn't have any place to store it if it wasn't what was needed. Now, at this project, I worked under a younger project engineer and a younger project manager. Now, I had thought that, with them being young, that I may not learn as much because they don't know as much. But actually, I learned more than I thought I would because I kind of thought of it different. Because they're young, they're going to make mistakes. And I can learn when they make those mistakes, which has changed my thinking and it really improved my learning during the summer. I really enjoyed my summer and I learned a lot. And thank you all for listening.